products of complex numbers. So let's say I have two complex numbers given to me in our trig form. I have r1 cis theta 1 and r2 cis theta 2, and I would like to multiply those two complex numbers together. Is there an easy way I can do this? Well, let's see if we can come up with a formula. Let's see, I want to multiply r1 times cis theta 1 times r2 times cis theta 2. That's technically 4 items being multiplied there. I'll multiply the two r values here at the front, and then I need to multiply the two cis portions. Let me go ahead and write those out, though, the long way. One of them would be cosine theta 1 plus I sine theta 1. And the other one would be cosine theta 2 plus I sine theta 2. Well, it looks like what I've created there is a FOIL problem, and that's exactly correct. So let's go ahead and FOIL this thing out. Let's multiply this then. From the first, I'll have cosine theta 1 and cosine theta 2. From the outer, looks like plus I times cosine theta 1 sine theta 2. Inner looks like plus I sine theta 1 cosine theta 2. And then the last is I squared, I times I, sine theta 1 sine theta 2. Okay, and then let me rewrite this just a little bit. If I is the square root of -1, that implies that I squared must just be -1. So this I squared we got down here is really just -1, which means the first term and the last term don't actually have an I. I'm going to write those first. So that would be cosine theta 1 cosine theta 2 minus, because of that -1, sine theta 1 sine theta 2. The other two pieces do have an I attached. And so what I'm going to do there is I'm going to factor that I out to the front. So I'm going to write plus I, open up a new parentheses, and then fill in those terms, and I'm actually going to reverse the order of those two terms. So I'm going to write sine theta 1 cosine theta 2, and then cosine theta 1 sine theta 2. All right, I know this looks like a mess, but we're just about there. Up at the top, I'm reminding us of a couple of our trig identities, namely the cosine sum identity and the sine sum identity. That's because I have the right side of those identities in my work here. Notice this first part, cosine angle 1, cosine angle 2 minus sine angle 1, sine angle 2. That's this. That's the cosine sum identity. So therefore, this is simply equal to cosine of theta 1 plus theta 2. Same thing with the other part. I have the I, and then I have sine first, cosine second, plus cosine first, sine second. That's this. Therefore, that second part is equal to sine of theta 1 plus theta 2. Well, this expression we've just ended up with is in trig form. It's got a modulus here at the front, r1 times r2, and then the rest of it is cosine angle plus I sine angle, which I can abbreviate with our cis theta 1 plus theta 2. If you look at where we started and you look at where we've ended up, you can see that we've come up with a very easy formula for multiplying complex numbers. Simply multiply the moduli and add the arguments. And that's it. Okay, let's put our new formula to use with a couple of examples. I've written it over here. If I want to multiply two complex numbers in trig form, multiply the moduli, add the arguments. Example A, 2 cis pi over 6 times 3 cis 5 pi over 6. I really don't even need to write this out in any kind of expanded format. I just follow the rule. Multiply the moduli. 2 times 3 is 6. And then add the arguments. Pi over 6 plus 5 pi over 6 would be 6 pi over 6, which reduces to pi. That's it. That's the product. It's as simple as that. Now, the directions will tell you put your answer in trig form, put your answer in standard form. If I wanted this in standard form, I could easily obtain it by switching to the longer version, cosine pi plus I sine pi. Pi is quadrantal, so we know those answers very well. It's right over here. This is the point -1, 0. Cosine pi is just -1, and sine pi is just 0. Well, the I part is going to go away. All you're going to have left here is 6 times -1, which is -6. That's just a real number because the imaginary part disappeared, but it is the standard form of that complex number, just -6. Example B is going to require a little bit more work because, of course, the original numbers themselves are not in trig form. Of course, there are ways of finding products in standard form, but our purpose is to use trig form. So I'll need to convert these two numbers into trig form, and then we can carry out the same formula that we just used. In order to do the conversion, quick pictures will help me. Let's see, the first one is 2 plus 2 root 3i. So I'm in the first quadrant. Here's my r, here's my theta. For r, I can use that polar relationship. It's really just the Pythagorean theorem. Let's see, 2 squared is 4. This 2 squared would be 4. Square root of 3 squared is 3. So that's going to come out to be 12. 4 times 3. Okay, so this works out nicely. I'm just going to end up, after I square root, with r equals 4. And then let's see, you may recognize theta already, but if not, you can use tangent theta equals b over a, which of course simplifies to just square root of 3. And you're supposed to think, I think I know this one, and you should. If the tangent ratio is square root of 3 over 1, then of course you're dealing with a 30, 60, 90 triangle, and that angle there is just 60 degrees. So my theta is 60, which means the first complex number, I'll rewrite the problem over here, is simply 4 cis 60 degrees. Okay, what about that second complex number? Well, this one's even a little easier. If I draw it out, 1 plus 1i, I immediately just make one of our very nice triangles. This is clearly the 45, 45, 90 triangle, and so I already know that the hypotenuse is square root of 2, and that angle is 45 degrees. So my second complex number is root 2 cis 45. Once I have the trig forms, I can follow our formula. Our formula said multiply the moduli. 4 times square root of 2 would be 4 root 2. And then cis, add the angles together. I had 60 degrees plus 45 degrees for a total of 105 degrees. And that's it. That would be the trig form of the answer. And then obviously, if you wanted to switch it into standard form, you could do so with the assistance of your calculator. Thanks for watching.